All right, the next thing we are going to learn about is shells. In 8.2.1, this is going to be our last topic or set of things we're going to talk about in calculus. So, this thing is the shell lab, and there's multiple shell labs that happen in the rest of Chapter 8. However, we're not going to be in class to do it. So, in 6-85, it says we're going to be looking at the however you pronounce that, dolls, with the dolls inside of each other. We are taking, so let's pretend that's a doll, and then we take another one, and then we put it inside of it, and then we take another doll, and, well, what are we doing with this? In order to calculate the volume, each of the dolls are fitting inside of each other until you get, like, the very center filled up. And what we're doing is we're adding up a bunch of very thin shells together. And so that's what we're going to be doing with our last piece of calculating volumes is instead of doing slices or discs, we're now going to be taking shells, and we're going to fill up the entire volume by taking a bunch of shells and adding them together. So that is what the cylindrical shell method is we are, if you imagine, we're going to try and figure out what the volume of this guy is. So with a cylinder that's got this part is hollowed out. So we're gonna take the outside part. So take the outside part, and we're gonna just make like a cut down right down the center, and we're gonna unwrap it. So if we unwrap it, then you end up getting a long rectangle, right? And then if we flatten it out, we'll end up getting a rectangle. So that's what it says here. It says a cylindrical shell is only a lateral wall of a cylinder, but when flattened, each shell becomes a rectangular prism with thickness dy or dx, which is going to be, whether we're talking about it lengthwise, this is going to be dx, and then if we were going the other way, this way, it'd be dy. The shells with gradually changing heights can be wrapped around each other to create three-dimensional solid whose volume can be calculated with an integral. So this is a typical type of shell at the right here. Unrolled, what shape will it be? It'll be a rectangle. The dimensions of the rectangle then, so let's just go ahead and do this one here. This will be f of x, and then this one would be our distance all the way around a circle, otherwise known as a circumference, and that is going to be 2 pi r. But the radius in this case is going to be x, because this is going to be our distance across, so it's not going to be 2 pi r, it's going to be 2 pi x, which means that if we were to find the area of this rectangle, it'd be 2 pi x multiplied by whatever our function is, because that's going to be our height, so f of x. There is a certain amount of thickness, though, and the thickness of the shell is dx, but it's infinitely thin. So if we were to find the volume of this shell, the volume would be 2 pi x times f of x times dx, and we can represent that as an integral. So that's what we're going to do. We're going to write this as an integral. We don't know how much we're going to be counting in terms of this. It could be this distance here, but we don't know what our function is. So we're going to say just from a to b. So we're going to go from a to b of 2 pi x multiplied by f of x dx, and that's the shell method. So using that, we're going to go ahead and calculate the volume of our example here. So 0.5 x squared, that's going to be this function. It's going to be the intersection of that from 1 to 3. So that's what we're going to figure out. So we're doing that, and we're rotating it around, and we're figuring out some guy that looks like this. And that's going to be our hole here. So there's going to be a hole there. And so what is the volume of that shape? We just need to plug in the information we have. We have 2 pi x, nothing's going to change there. We're going from 1 to 3, so we're just going to make this integral from 1 to 3 of 2 pi x. Our f of x is going to be what our function is, so 0.5 x squared dx. And that's it. Just evaluate that integral. I did earlier, so I'll just go ahead and show you. Turns out that's a special number. If I divide that by pi, I'll get 20, which means that our answer is going to be 20 pi units cubed. We're going to do further examples in the next couple of days, but I just wanted to introduce you to that shell method. It's just us taking we'll pretend like it's the dolls example, I guess. So, all right. Got 2 problems for homework, and I'll see you later today.